Hey guys, today we are going to talk about function notation. You have learned some things about functions. You know that functions can be shown in several ways. For example, by a table of coordinates, by a map that shows those coordinates, by a set of ordered pairs that shows those coordinates, or by a graph, which, if I can get these dots fairly close to where they ought to be, would create the line that shows what that would look like on a graph. There is another way that we can show functions, and it is with equations. So I need you to dig back deep into your brain from probably several years ago, maybe last year. I'm not sure when you may have done this before, when you had to take a table of values and turn it into an equation. Show the equation where if you put this x in, you would get this y out. And there are several ways to do this, but as it turns out, if you take the x value and multiply by 3, and then subtract the subtract 1, there you go, you get the y value. So if you take your x value, multiply by 3 and subtract 1, 2 times 3 is 6, minus 1 is 5. You get the y value. For the third one, if you take the x of 3, multiply by 3, this is going to give you 8, which is your y value. And if you take your x of 4 and multiply by 3 and subtract 1, you would get 11. And what we can say is that in order to get y equals 3 times the x value minus 1. And we can turn this into an equation. Now, you're not going to have to do that right now. This is just sort of jogging your memory about how the fact that a table of values can also be made into an equation. So that's the fifth way that a function can look, okay? And this equation here, y equals 3x minus 1, this represents the line that we saw back here on this page. And so do, for that matter, all of these representations are all the same as y equals 3x minus 1, okay? So we just want to be thinking about equations, okay? But not all equations are functions, though. So for an example, here's an equation, y equals the positive or negative square root of x. This equation does not represent a function because it kind of looks like this. If you were to go into Desmos and do y equals the positive square root of x, you would get the upper half like this. And if you do y equals the negative square root of x, you would get the lower half. And so when you put those two together, you get this graph here. And of course, as we know, the vertical line test is not going to work because it goes through twice. So just because we have an equation doesn't mean it's a function, okay? So if an equation does represent a function, it can be written like this, or we can take out the y and put in f of x, where f of x replaces the y, and it does not mean f times x. I know we're used to seeing parentheses meaning multiplication, but in this case, the parentheses does not mean multiply. It means function of x. And that's actually what you say when you read it. So fx equals 2x plus 3, you would say function of x equals 2x plus 3 if you're going to read this out loud, okay? So the f of x is telling us that 2x plus 3 is a function. I would not be able to say f of x equals positive or negative square root of x because we just saw from the last page that that's not a function. So I would not be able to write that one that way. I'd have to use the y, okay? But for this one, since we know that 2x plus 3 is a function, I could take the y out and put f of x in. So the important thing to remember is that this is just an equation with the y taken out and f of x put in. And with function notation, we can substitute values for x and find y, just like we did with the table earlier. It just looks a little different. So this is what the problem might look like. If f of x equals 2x plus 3, find f of 5. So what they want us to do is recopy the problem, substitute 5 where the x's are, and then simplify. So I'm going to write it here. I'm going to write the original. And this is what you have to know how to do today. If it says to find f of 5, I'm going to recopy, but this time instead of f of x, I'm going to put f of 5. I'm going to keep all the rest of it the same. Now what I'm going to do is I'm going to take this 5 and I'm going to substitute it where I see x. And remember, we did substituting way back in the day, and remember that you always substitute inside parentheses, right? 2x would not be 25. It's 2 times 5. And we're going to use parentheses to show multiplying. And then we just simplify. 2 times 5 is 10, and 10 plus 5 is 15. So the answer to this problem is 15. Let me show you some more examples. The first one says f of x equals negative 2x plus 1. Find f of 4. So we're going to rewrite, but instead of f of x, we're going to put f of 4, which is what they gave us, and we're going to copy the rest of the problem carefully. Then I'm going to take this 4 and I'm going to put it where x is. Keep the negative 2, substitute inside parentheses, copy the rest. Oh, there's Kitty Cat, she's awake. Now we just simplify. Egypt, I'm in here. Negative 2 times 4 is negative 8, and negative 8 plus 1 is negative 7. And that would be the solution to that one. Why don't you pause the video and try this next one, and then hit play again when you're ready to check your answer. All right, so I have f of x equals 5x minus 2, and we're going to find f of 2. So we're going to recopy with f of 2 underneath the problem. And I'm going to put 2 in where x is. 5 times 2, use parentheses. Now simplify. 5 times 2 is 10. And 10 minus 2 is 8. If you got 8, congratulations, you did it right. Let's look at a couple more. Now what you might find different about these is that they don't say f of x, they say g of x. But we can have functions that are named by any letter, really. F is the most common one, but you might see g of x and then find g of negative 2, or h of x and find h of negative 7. We're going to do these problems the exact same way. All right, so g of x equals negative x plus 1, so find g of negative 2. We're going to recopy, and then we're going to substitute negative 2 for x. Now be very careful, because notice here that x has a negative sign in the front. That negative is not the same as the negative 2. This is why we substitute inside parentheses, so that we can see that we need 2 negatives there. The negative stays, x is negative 2, and then the 1 is 1. Well, what's negative negative 2? That would be positive 2. So this answer is 3. Okay. Why don't you pause the video and try the next one, and we'll see how you do. All right, if I have h of x equals 2x, and I'm going to find h of negative 7, I'm going to recopy, and then I'm going to put negative 7 where the x is. So 2 times negative 7 is negative 14. That was an easy one. All right, and I have one more to show you. What if, and I have to write this one, what if you have more than one x? So for example, j of x equals x squared plus 3x. Can you hear her? Egypt, come here, baby. She woke up from her nap and she wants to know where mommy is. All right, so we have j of x equals x squared plus 3x, and we're going to find j of negative 3. So even though we have 2 places where x is, that just means we're going to put negative 3 in twice, okay? So we're going to, same process, copy the problem, substitute inside parentheses, and this time we're going to substitute in both places, right? Because I have 2 x's, so I'm going to substitute twice. And then simplify. Negative 3 squared is 9. And 3 times negative 3 is negative 9. Well, what happens when you have a plus minus? You may remember that turns into a minus, and 9 minus 9 is 0. Okay, so what you're having to remember here is your order of operations. Remember GEMDAS, right? So this is basically, we're doing order of operations again, just not terribly complicated. And we are just substituting and simplifying. And that, guys, is pretty much everything you need to know for this stage of function notation.